In today's lecture, we'll try to explain black body radiation and photoelectric effect by using Planck's quantum theory. So first of all, we'll try to take black body radiation. We know that heated objects in a hot bodies, they emit radiations of different frequencies or different wavelengths. If we take an example of iron bar, heated iron bar, it becomes first red. If heating is continued, then it glows with yellow light and finally with white and blue light. Why this color change? We'll try to explain this. So when substances are heated or when a substance is heated, atoms are set into oscillation. Atoms are set into oscillation and they emit radiation of frequency V. As heating is continued, यानी जब हम हीटिंग को कंटिन्यू करते हैं, हीटिंग कंटिन्यू करने का मतलब more and more energy is absorbed and they emit, that means atoms emit radiations of higher and higher frequency. So we know that, हमें पता है कि रेड जो है from the electromagnetic spectrum में पता है red has minimum frequency whereas yellow has higher frequency. That is the reason the iron bar first becomes red, then yellow, and so on. Now we'll take different points of photoelectric effect. Einstein in 1905 explained different points of photoelectric effect by using PQT, Planck's quantum theory. What is the first point? Einstein has observed that when light of a certain minimum frequency, in a radiation of a certain minimum frequency, strikes the metal surface, electrons are ejected from the metal surface. These electrons are known as photoelectrons, and the effect is known as and the phenomenon is known as photoelectric effect. How these electrons get ejected? So we'll try to explain. इसको हम explain करने जा रहे हैं. इसको हम explain करेंगे. When a radiation of certain minimum frequency known as threshold frequency strikes the metal surface, we know that radiation is made up of stream of particles called photons. So photon gives its entire energy to the electron of the metal atom. यानी फोटॉन अपनी पूरी एनर्जी इलेक्ट्रॉन को देता है, मेटल एटम के इलेक्ट्रॉन को देता है. जो मेटल एटम में इलेक्ट्रॉन है उसको देता है पूरी अपनी एनर्जी. अब जो इलेक्ट्रॉन इट विल गेट डिटैच्ड, ये डिटैच हो सकता है इफ द एनर्जी ऑफ द फोटोन इज सफिशिएंट टू ओवरकम द फोर्स ऑफ अट्रैक्शन ऑफ इलेक्ट्रॉन बाय द न्यूक्लियस. इसका मतलब है तब इलेक्ट्रॉन डिटैच हो सकता है अगर फोटोन की एनर्जी उतनी ज्यादा है, उतनी सफिशिएंट है ताकि वो उस फोर्स को, जो इलेक्ट्रॉन और न्यूक्लियस में जो फोर्स है, फोर्स ऑफ अट्रैक्शन है, उसको ओवरकम कर सकता है, तब इलेक्ट्रॉन डिटैच हो सकता है. दैट इज व्हाई इलेक्ट्रॉन्स आर इजेक्टेड ओनली व्हेन द इंसिडेंट रेडिएशन has, यानी which strikes the metal surface has certain minimum frequency known as threshold frequency denoted by V naught. If the incident radiation which strikes the metal surface has frequency less than threshold frequency, that will not be able to, the photons will not be able to eject the electrons from the metal surface. The second point was the velocity of the electron increases with the frequency of the incident radiation. Why so? We know that if the frequency of the radiation is more than mu zero, that means threshold. If the frequency of the radiation which strikes the metal surface is more than mu zero, in a threshold frequency, the excess energy is imparted to the electron as kinetic energy, thereby increasing its velocity. More the kinetic energy, more the velocity. That means h nu minus h nu 0 is equal to 1 by 2 mev square, where m is the mass of the electron and v is the velocity. This term is kinetic energy of the electron. This energy difference is important to the electron as kinetic energy. This energy difference. So we can write this equation: h nu is equal to h nu 0 plus 1 by 2 mev square. So what is this? We can write this equation also like this: w0 plus 1 by 2 mev square. What is this? This work function. So the excess energy is imported as kinetic energy to the electron. That is the reason. More the frequency, more is the Ke of the photoelectrons, and more is the velocity. More is the velocity. More the Ke, more the velocity. More the frequency, more the Ke, and more the velocity. The third point was that by increasing the intensity of a particular of radiation of a particular frequency, the number of photoelectrons increases. The number of photoelectrons increases. Why so? If the intensity of the radiation, if the intensity of a radiation of a particular frequency, intensity, brightness of the radiation of a particular frequency is increased, that means we are increasing the number of photons. So more the number of photons, when there is more number of photons, that means more and more photons will give their energy to the electrons, and more electrons will get detached from the metal surface. Therefore, the number of photoelectrons ejected or produced will be more. But the energy of these photoelectrons will not get altered. That energy only depends upon the frequency, as we know the relation E is equal to h nu, where h is Planck's constant and nu is the frequency of radiation. So by increasing the intensity of the radiation of a particular frequency, the number of photoelectrons ejected increases, but the energy of these photoelectrons remains unchanged or unaltered. Hope that you have got it. Thanks.